Hi, Namastey Coders. I hope you are fine, doing well in your life. So, today is 4th March, and we are gonna solve the problem of the day on LinkedIn on LeetCode, right? So, uh, after so many days, I am uploading a new video. Sorry for the inconsistency. Actually, I got some uh, work to do where I got stuck and not able to upload videos. But from today, I will continuously upload problem of the day videos, right? So let's start today's problem. So before starting this problem, I will tell you that this video is a part of LeetCode problem of the day series, in which we are committed to solve LeetCode problem of the day. And along with the LeetCode problem of the day, we are also solving LeetCode 75 series. These LeetCode 75 problems are the most important problems that will most probably come into your interviews, right? Along with these two series, I have also created a WhatsApp group for the coders along the world. So if you want to connect with the different coders of this world, you can join the WhatsApp group. That's completely free. The link is given in the description. So let's start with the video. So in this video, first we will discuss the problem in detail. What is the what is the given, what is expected to us, and then we will try to solve this problem using the native approach. Then after it, we will try to optimize the native approach. So the problem is given an integer n, return true if it is possible to represent n as a sum of distinct power of 3, otherwise return false. Okay, an integer y is a power of 3. Okay, so the problem is pretty simple. We are given n, and we have to check that if we can divide this n into the power of 3's, and the power should be distinct, right? So let's take the example of 91. 91 can be divided as 81, which is 3 to the power 4, right? Remaining 10 can be divided as 3 to the power 2, which is 9. So this is 9. 3 to the power 2 plus 1. Okay, so 3 to the power 0. So taking the example of 21, right? 21, first of all, we have to take 9, and remaining is 11. So we cannot 12, right? So 12 cannot be made as 3 to the power anything. 12 can be made as 9 plus 3, right? But we have already took 9, so we cannot take 9 again, because we have to use distinct power, right? So the 12 is not possible. This 21 is not possible. 12 is possible, right? 3 to the power 2 plus 3 to the power 1 is 12. Okay, so how to solve this problem? So first thing we have to check, we have to keep in mind is 3 to the power x is always greater than 3 to the power or any n to the power k. N to the power x is always greater than n to the power summation of n to the power I, where I belongs to 0, say x minus 1, right? For n greater than 1, n integer greater than 1, right? This is the condition, and this is the property. So for any 3, let's take the power 3 to the power 3 is always greater than 3 to the power 2 plus 3 to the power 1 plus 3 to the power 0. Okay, because 3 to the power 3 is 27, and 3 to the power 2 is 9, 3 to the power 1 is 3, 3 to the power 0 is 1, so this is 13. Okay, so keeping this property in our mind, what we conclude that if we have anything like x, so we have to find the greatest power near x, right? So let's say we have 91, right? So what is the greatest power of 3 which is near 91? It is 4, right? So we have to take 3 to the power 4 first. So 3 to the power 4 is nothing but 81, and we have to subtract 81 from 91, which came out to be 10. Now we have to do the same thing with 10. Okay, so that's, and finally if we have n equals to 0, we will return true, otherwise we will return false. So this is a recursive method. This is a native recursive method in which what we'll check the maximum 3 to the power near this number. So we have n, we have to find maximum power of 3 near this number, and we have to subtract that number and find again all these things using recursion. Okay, but can we use something else instead of this recursion? So I've solved this problem earlier and find the solution. I've solved this problem with 100% beat. See, 100% beat, right? So I'm going to explain to you what I'm doing is first thing to keep in mind is we have n which is greater than 10 to the power 7, right? So we have n which is 10 to the power we have n which is greater than 10 to the power 7, right? So what I'm doing is I'm creating a array of all the powers of 3, right, till my greatest number will become smaller than 10 to the power 7, right, is smaller than or equals to. So I'm creating this array, and I found out that only 15 numbers can be possible. So I'm creating an array of length 15 in which I'm putting all the powers of 3 which is smaller than or equals to 10 to the power 7. Now what I'm doing is I'm iterating from the greatest power to the smallest power, right? Greatest power is 10 to the power 14, sorry, 3 to the power 14, and smallest power is 3 to the power 0. Okay, so I'm iterating through 3 to the power 14 and checking if n is greater than that number. If that is the case, so this is the case like 81, right? If that is the case, I'm subtracting the power. I'm subtracting that number from that n and doing this loop again. This will prevent our recursive calls, and we can use the loop. That is also a similar kind of a thing, but we don't have to check again and again the nearest power of that number, right? We are using every power, and if n is greater than that power, we are subtracting that power. And finally we will check that if n is equals to 0 or not. If n is equals to 0, we will return true, otherwise we will return false. So that's how we are solving this problem. We are solving this problem in 100% beat. 100% beat, right? So that's all from my side, guys, in this video. I hope you understand it well. Thank you for your time. Again, I want you all to join that WhatsApp group. That is a very important for everyone. If a community grow, we all will grow, right? So thank you for your time. Thank